Hello and welcome to Tuesday's edition of Cracking the Cryptic. And welcome to those few minutes every day where we get to spend time together doing puzzles and solving problems that actually have solutions, and hopefully solutions that we can find within a reasonable time frame. And as usual, we're going to be trying today to do 2 videos to get you guys through lockdown, in the best way possible. We actually got, it reminds me, we got an amazing email yesterday on the channel, and I've posted it on Twitter, and do check it out. I mean, it was humbling to receive an email which basically said that we are really making difference to people's lives, and if we are in some small way making a positive difference, that is tremendously, well, it's amazing. And Mark and I are both very proud of that, to the extent it's true. Now, what are we going to be doing today? We're going to be trying this puzzle, which might be a fool's errand. This is a puzzle which appeared on, well, actually I was sent it by Matyas Martinka, who created it specially for the channel, he says, because it combines Sudoku with sort of pencil puzzle logic. I think looking at the rule set, it sounds like a cross between Sudoku and Nurikabi, for those of you familiar with Nurikabi logic. So I'm desperate to try this. It's not been tested by any of our testers. I've relied on the feedback on Logic Masters Germany to give me a feel for A, how difficult the puzzle is, and B, how good it is. Now, in terms of how good it has a 99% rating. It's been solved 21 times. It's rated 4 stars out of 5 for difficulty, so I'm hoping that means I'll be able to get through it. But I read the rule set and said, look, I've just got to do this puzzle. So I've stuck the webcam on. We're going to do it. I'm going to do it, and we'll see how we get on. Now, firstly, I should read these rules. These rules they're interesting. Right, normal Sudoku rules apply. Each cell in the grid should be coloured blue for water or green for land. For cells containing arrows, the digit in that cell shows how many cells share the same colour with the cell in the given direction, not including the arrow cell itself. Note that these same colour cells need not be connected to the arrow cell. Not all arrows are given. The water occupies a single orthogonally connected region of the grid, but no 2x2 area can contain only water cells. An island is an orthogonally connected region of at least 3 land cells. Islands may touch each other diagonally. Land cells forming any island must contain different digits. Wow. Now that's a rule set, isn't it? That sounds fascinating. But for those of you familiar with Nurikabi, it does sound to me very much like the land cells operate like Nurikabi, which of course allows you to draw islands in the grid. The only distinction being that in this puzzle it seems that we can't have a 2-cell island. Each island must be at least 3 cells large, and also once we get to it, we can't repeat a digit in an island, so islands behave a bit like killer Sudoku cages. Wow, I mean, I think the best way to do this, I'm just going to sort of jump in and see what we can find out and how the logic develops. What could be better than that? So if you want to have a go, click on the link under the video. That will take you to this web page where you can play along with that. Let's get cracking. Now, actually, I can place a digit in the grid. Look, that must be a 1, mustn't it? Because whatever colour this is, we're saying that there must be, we can't put a 0 in here. So there must be, this cell, whatever it is, must be the same colour as this cell. Otherwise this cell would have to have a 0 in it. So this has to be a 1, but we don't know whether it's water or land. So let's look for more arrows near that one. That can only be a 1 or a 2, I guess. Oh, 3 in a row there. They can only be 1, 2, and 3 because there's only 3 cells to the left of them. So this forms a triple straight away, look, in column 4 of the grid. So that square can only be 4, I think, because 1, 2, 3, 4. That's the maximum number of cells beneath this arrow. That can only be a 5 for the same reason. 1, 2, 3, 4, 5. Well, so far this is very straightforward. That one can only be 1 or 2. That one can only be 1 or 2. That gives a pair look. Oh, 2 there, look, close to those have got to be 1s and 2s. That creates another 1, 2 pair. Oh, that 1, 2 pair sees that through. That's got to be a 3 therefore. So this... so that 3, look, that sees 3 cells that way that all have to be the same colour as this cell. And, oh, that cell's got to be a 4. Because 1, 2, 3, 4, that's the maximum it could be. Let me just look at this for a moment, because whatever colour this is, it shares a colour with all of these cells. So all of those cells are the same colour, and all of these cells are the same colour. But there's an arrow here. Now this arrow, the minimum digit we can put in there is 5. Now if these were 2 different colours, well, it's not possible they're 2 different colours, because there's 5 purple cells there. There certainly isn't 5 brown ones. And if this was pointing at 5 different or 5 same coloured cells, it would have to be purple. So this would have to be purple, which means this is also purple. So this is all purple. Now we don't know, do we? It can't be land, surely. No, it can't be land, and the reason it can't be land is that if it's land, one of 2 things would happen. Either there would be some water up here, and that water is going to be disconnected from whatever water we find down there, and that breaks the puzzle because we know the water must form a single orthogonally connected unit, or there is no water up here and this is all land. But if this is all land, we've now got to fill these 27 cells with different digits. Well, that's not possible. There are only 9 different digits in a Sudoku. So actually, we know for sure that this must all be water. Which means that cell must be land, because if this is water, we therefore know this would be water, and that creates a 2 by 2 water region. This is already very interesting. Oh, wait a minute. We've got 2 cells here that can't be 1 or 4, but the maximum they could be would be 4. So if they can't be more than 4 and they can't be 4, they've got to be 2 and 3. Oh, hang on, look. There's like a chain going on here, because this 5 sees all these squares. So this is a connected unit, and this 4 sees all those squares. So this has to be the same colour. So there's an enormous region here. And that square can't be a 1 or a 2. That's very interesting, because now this square, if it can't be 1 or 2, it must be purple, because it's going to be 3 or greater, and the only way of getting to colours totaling 3 is to include purple colours. So if the minimum this could be would be 6. And the maximum would be 8. This is 6, 7, or 8, depending on how many purples we get in those 2 squares. There's 5 here. So if this is 6, that one will see five purples, and that's not possible. I think, let's just look at this. If this is 6, these two are therefore not purple. They're some other colour. Let's make them brown again. So now, how many purples does that cell see? It sees 5. So this would have to contain a 5, and it can't. So this is not 6. Now if it's... this is nice. If this is 7, this one breaks instead. Because 7, now one of these needs to be purple now to fulfill this clue. Let's say it's that one. So now what is the total of purples this sees? 1, 2, 3, 4, 5. So that has to have a 5. So actually this square cannot be 6 or 7. It's got to be 8. Let me just... So this is an 8. And all of this is purple. Purple, not blue. It might be blue. It is blue. In fact, it is blue because... if all of this was green, it's too big again. It's bigger than 9 cells, so we couldn't put different digits in it. So this big region here is blue. We can't create 2 by 2s, so those two are green. These two cells are 6 and 7 now, because that sees 6 blues, that sees 7 blues. Sorry about this. 1 second. Let me just... So this arrow... This arrow can't be greater than 5. So it's got to be 4 or 5 because it can't be 1, 2 or 3. And it can't be 5 because if it's 5, because this square is blue... all of these squares have to be the same colour, so it would have to form a line of blues like that. But now we've got a 2 by 2 blue region. So actually, this just cannot be 5 because this square is blue. That's lovely. So this is 4, but now it could be blue again. It can be blue, I don't believe it. So even once you disambiguate its colour based on a colour, it can then switch and become that colour again. I'm trying to pick the arrows that look like they're the most restrained. I presume that is the correct strategy. Now that arrow, look, sees a 1 and a 2 in the box and a 5, 6, 7, 8 in the row. And it can never be 9 because there aren't 9 squares above the arrow. There are only ever 8. So this is a 3 or a 4. Oh, here's some logic for you. Oh, this is very, very nice. Look, this is a blue 3, 4. So what is this? Look at the arrows pointing at each other. This can't be blue. Because if it's blue, this arrow and this, well, this cell and this cell need to have the same total in them. Look at that. So just to explain what I mean there, let's say that was a 4 because this one sees 4 blue squares. Well, if this is blue as well, these 7 cells in the middle of the column are common to both, to both arrow clues. So whatever we've got in here, plus 1, should be in this cell, and whatever we've got in here, plus 1, should be in this cell, the same totals. So that cannot be, that has to be green. Oh, that is absolutely lovely. Oh, and that's not that. Hang on, I mustn't get confused about that. That's a 3 or a 4, and it's blue. I want this to be a 3 or a 4. I'm just trying to think about. That's what my intuition is saying. That's right. This square can only be a 3 or a 4. Oh, this is so lovely. Look at this. This square. This square is blue, and we know this square is green. So this square is the count of those 7 squares. It's not counting this square. We know this square is not blue, so it's not counting. So this square's total is going to be the total of blue squares in that 7-cell region. Now the total for this green square, this isn't green, remember, is the total number of green squares in that 7-cell region. So we know that there are 7 cells being counted here. They're being divided up between green and blue squares. Therefore, this and this must add up to 7. That's a 3 or a 4. This can't be a 3. That's a 2. That's a 3. Oh, this is sensational. Surely I can disambiguate this 2-3 pair. Not sure I can. This could be all blues, or it could be all greens. Oh. Ah, no, that's not working either. Ah, no, hang on, we could do something with this. I could have done it for a while. This can't be a 2 here and a 1 here. Because if it is like that, these 2 cells and this one all have to have the same colour. And now this 1 clue can't be fulfilled because it needs to be a 3 clue or a 0. So this can never be 2. This is a 1, this is a 2, this is a 1. This 1 sees the 2 down there, that fixes all this. This 2 is now green, so, well, it was green before, but it extends the green. This 1 clue, look, is ambiguous. Ah, that's interesting. There's an interesting thing from the setter's perspective there. What is the purpose of this 1 clue, given it doesn't disambiguate these two colours? Its purpose was to form the 1-2 pair here, which restricted what the value of this square could be. It forced this square to be at least 3, which allowed us to do the logic on the bottom row. That's very nice, isn't it? Must be oh, no, 2s. We can do 2s. That must be a 2 by Sudoku. I haven't said that much. Ah, of course. This is a 1 clue, so this can't be green, because then it should either be a 2 or a 0. It's never 1, so these have to have different colours. The blue has to connect to its friends. Let's connect it. Can't create a 2 by 2 region. This could still be either way round, I think. As could that one. Bother. Ah, no, we can do some logic with the 4. So if the 4 is green, it's clearly all of these 4 cells are green. If the 4 is blue, yeah, this is good, this is good. If the 4 is blue, we know this square can't be blue as well, because that will create a 2 by 2 blue region. So this square can't be blue. Now there's only 4 more squares in this column that are blue, so we'd have to do that. and that parcels off this domino. This green domino is not of size 3, which it needs to be, at least 3. So this I don't think can now be a blue 4. I think it has to be a green 4, and that means all of these are green. The 2 clue now can't get to 2 blues, so it must be green. The 1 clue must be blue. That's its only option, because there's already 2 greens to the left of it. What a puzzle, eh? What a puzzle this is. Oh, look. Now if this 3 clue is green, I have to connect all of those and be green. And now this green area is bigger than 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, that's impossible. We couldn't put different digits into them. So that clue is blue, which means these 2 clues are also blue. The blue here has to get out. So it's got to come through this little gate. Look, that must be blue, and that must be blue. This mustn't be a 2 by 2 region. How do we get the value of this? Is this 2 blue or is it green? Okay, so the 3, yes, this cell can only be a 3 or a 4. There are already 4 greens in the column. So if I make that green, this would have to be 5. We know it can't be 5. It must therefore be 4. That's a 3. This is a blue. Fours. 4's there. I mean, Sudoku rules. We can just place a 4 into that square. 5, 6, 7 here. Where do we put 5, 6, 7 in this box? They're going to have to be in those squares, which means that square must be a 9. Threes must be resolvable. Yes, they are. That must be a 3. Sorry about this. Just let me stare at this for a moment. Oh, that square, of course. That's been there from the start. I just didn't notice it or something. That's got to be 7. 1, 2, 3, 4, 5, 6, 7. That means that one's a 7. That fixes a 5, 6 here. These two have got to be 8 and 9 in some order. 7's in one of those 2 squares. Oh, 7. No, 7 can't be here because that's blue. And the maximum number of blues would be 6. So this is not 7. So 7 is up there. So it's the same with the 9. Look, the 9 on this box. If 9 can't go here, can 9 go in this square? Well, no, because that would imply there are 9 blue squares in only 8 cells, 2 of which are green. Well, I can work out that's not right. So 9, 8 in that order. So in fact, this square must be 5 or 6 because it can't be 8. So the 8 is in one of those 2 squares in the box. That means, oh no, hang on. That's a 5 or a 6, isn't it? And the 8, this is a 5, 6, 8. Options, this is 5, 6, 8. 5, 6, 9, sorry. Yeah, that's better. 6, 8. 6. Oh, I tell you what. Can this green region here come through this gap? Now, if it does, if this is green, what number is it? Oh, could it be a 6? Yeah, it could be a 6. That doesn't work. I was hoping I could restrict it because I've got 1, 2, 3, 4, 5 in the column. And it can't be an 8 because we know the 8's in one of those two, but it could be a 6. I can't see why it can't be a 6. So that's false trail, sorry. Let's go back to white there and look for something else. Ah, we've got this again. Look, 5, 6 here, and the opposite, an arrow opposite it. So these have to be different colours. So this has to be green. Oh, this is so clever. This has to be 5 then, because there are only space for 5 blues, and that has to be a 2, because there's only 2 greens. Would you credit it? I mean, that is just... So that's 5. Oh, and now the 6 is in here, so this can't be 6. So this has to be blue. Because there's no valid option for this square if it's green. That must be 5. Oh, the green 2 sees those squares. 2, 1. That's blue, so those are both blue. One of these squares is green because of the 1 clue, so there needs to be 3 green squares in this little 2 by 2. Well, if those were the green squares, that wouldn't work because the blue square would be isolated in the corner. So actually, we know that that square is green, and therefore we know this square must be blue because this needs another blue square, which forces those two to be green. That square's got to be green to avoid a 2 by 2. And that one. Actually, there's a few of these. Look, I've missed them all. Those, that one. Those are all got to be green. Now this square has to be green. Because if it's not, if this is blue, this square needs to be green to create a size 3 region, but that's going to isolate this blue square from its friends. So actually this square is green for certain. Good grief, this can't possibly be a 9-cell region, can it? 1, 2. If that's green, this will be a 9-cell island. What's this arrow? Oh, I don't believe it. It is, look, because this sees 4 green squares at the moment, and there's already a 4 in the row, so it can't be a 4. Its only option is to be a 5, which means that square does turn green, and now we have a 9-cell green region. I don't believe it. Oh, and that means that square's an 8, because there's already an 8 in the green region, and it can't go there. Holy moly. Now this is a 6 or a 9, just to complete the row. There must be a 5 in one of those 2 squares by Sudoku. Threes and 8s, look. These 2 squares are 3 and 8 in some order. Presumably I can... Oh, my phone's buzzing at me. I'll ignore it. What am I meant to see now? Oh, 2s. Look, there's 2s. That's got to be a 2. Don't think we can tell which way round that is yet. Not sure. This square, look, that sees a 1 and a 2 in the row, and it sees a 5 in the box, and it's already got 2 of each colour placed, so it can't be a high number. The maximum it could be would be a 4 if you know, 2 greens joined another 2 greens. So this has got to be a 3 or a 4. Now, can we see which? Not sure. Oops. Column 9, 1, 2 here. So this can't be a 1 or a 2, so there must be a 1, 2 pair there. So this square is a 4, just to complete the row. That means there's a 4 in one of those 2 cells, and in one of those 2 cells. Oh, and where does 4 go in this box? Those 4s point at that square. That's got to be a 4. Oh, and that is helpful. That is helpful because now, look up here. If this is a blue 4, these 2 squares would have to turn blue, and that creates a green domino, which we mustn't create. We need it to be bigger. So this square is, not only is it a 4, but it is a green 4, and that makes those 2 green. So this is counting the number of green cells beneath it. So it's got to be, that's got to be a 2 or a 3. This square can't be a 4, whatever colour it is, because there's already 5 greens and you can't get to 5 blues. So this is a 4. This is a 4. This logic in this puzzle is so original, it's just stunning. It's got to be a 2 in one of those. Now this square, could it be a 1? Oh no, it can't be a 1. Can't be a 1 and it can't be a 2, so it can't be blue because the blue clue would only be a 1 or a 2. This is green. 2, 3, 4, 5, and it can't be 5. It's got to be a 6, which means they're both green. That disambiguates the 6 and the 8. This 6, 9 is now, look, that fixes all of that over that side. These 2 squares have got to be 6 and 7. These 2 squares have got to be 5 and 9, therefore. So these 2 squares will have to be, what's the difference there? 6 and 7, which we can resolve. There's a 6 here. So that's 6, that's 7. That's 7 by Sudoku. The 7 over here disambiguates it. 6s are now placed in the main anyway. It's quite surprising that this puzzle is still not finished, is it? By any manner or means. So we've got the 2 here. I've got the 2 here. So this now has to be, this now can't be green because I've got 3 greens up here. So this must be blue, which means this must be green to avoid a 2 by 2. This must be green because I've got my 2 blues up there. This 7 can't be green because if it is, look at that. I've already got a 2 in this region over here. And that would create 2 2s in the region. So that's blue. this green has to come out. It's got to be at least size 3, so both of those get to be green. Wow. So this is now filled. I still don't know what this one is. And this one... one of those two squares has to... that's helpful. One of these two squares has to be a 1 because of these ones. Now it can't be this one because this already sees 2 greens and many more blues. So that cannot be a 1. The 1 is here. Which means these two squares are 3 and 8. That's resolvable. 3, 8. 8s move over there, look. 3s... 3s are in the same places as 2s. So this is a 2-3 pair. Which means that these two squares have got to be 5 and 9. And the 5 is helpful. So now we're starting to cook with gas, aren't we? 5, 9... These have got to be 1, 9, that's resolvable. 9, 1. 1 must... This is 1, 5 here. These squares are 6, 7 and 8 to complete the row. 3. I still haven't done this arrow. I've still not done that arrow. So these two arrows are going to be how we finish the puzzle. 3, 5, 8. Let's look at the options for this then, because this one can't be 8 because there's not, this isn't a single colour above it. So this is 3 or 5. That's interesting. So if it's 3, it's green because there's already 4 blues above it. So it's either a blue 5 or a green 3. That's it. Look at this. If that's a 3 and it's green, the puzzle breaks. Can you see why? Pause the video if you can't. It's really lovely. Again. Look, where do we now place a 3 in this box? We can't put one in the green region because it's already got a 3. We can't put one here. So the only valid square would be that one, which we don't know whether that's blue or green yet, but that's definitely in the same row as this 3. So that is not what we do. This must be a blue 5. And that, 1, 2, 3, 4, so this is a blue 5 then. Sorry, a blue 9. Now this must be blue in order to not isolate it. That's how that cell gets disambiguated. So we've almost got the whole grid filled now. This is a 3 or an 8. And so what do we do to finish this off then? 3, 8, 9 into those squares. Surely I can disambiguate. This cell is annoying me. How do I tell what it is? Do I have to fix this one first? Six, 7 and 8 into those squares. This can't be a 7. So, what is it I'm meant to be spotting here? Also, I suppose I need to know the parity of this one as well. I haven't got that yet. Of course, I have to avoid 2 by 2 regions. That's what I'm forgetting. So both of these are green. Therefore, this clue up here does get fixed. That's got to be 3. That's 2. Now, has that fixed it? Yes, that gets me 2, 1, 1, 5, 5, 9. 9 must hide away here now. Still not done. Oh, the 3. This can't be a 3, because then I can't put a 3 in here again. I don't believe it did double duty. Therefore, that must fix like this. 3, 9 here is now resolved. That's a 3. That's the elusive 3 we've been trying to place in this box all this time. Now, please don't have broken it, Simon. The 8 here gives me a 6. That resolves the 6 and the 5. This can't be 8. This can't be 6. This one can't be 6. This has got to be 7, 8 pair. The 8 comes in again. I don't believe it. This 8 forces that one to be the 7. This is a work of sublime genius. Absolutely extraordinary. Please be right. Yes, I absolutely love that puzzle. That is just mesmerising. Matyas, thank you very, very much for sending that and creating it, especially for us. Wow, what a treat. What a treat. I hope you guys enjoyed it. Let me know in the comments. I really think Matyas deserves to get some plaudits for this puzzle. That is as good as it gets. Fantastic. Wow.